Hello everyone, my name is Romain and I am a QA automation engineer working in video games. I spend a lot of time advocating for test automation in video games because this is something that is not very common in the industry. And why I do that, usually I have questions asked from people where they wonder how to get started, which tools they should use, and some people already have automation, but they don't necessarily know how to move forward. So that's the origin of this talk was to show how to build the first vertical slice of test automation inside a game team. The first vertical slice here means building a small but complete pipeline where all the key layers of automation, from defining the test cases to notifying the results to people, are connected and working together. Initially, I did this presentation during the Game Quality Forum this year, 2025, in Lisbon. It was well received, and I wanted to do it again on LinkedIn, so people could have access to it without having to go to the conference, because some people couldn't join the conference. So hopefully you find it useful. Um, the presentation is split in three phases that we can see here: the tech, the people, and the blueprint. The audience is usually people that want to implement test automation inside their existing team, or maybe you already have automation, but you're not sure exactly in which direction you want to go. So hopefully this talk can actually help you give a direction to where you should go, or at least to confirm that the path you're taking is the right one, or at least a good one. So let's jump into it. First, we have the tech. I'll explain the two main archetypes you can find when choosing a test automation tool and why it matters. First, there is the client-server instrumentation archetype. This is the Selenium or Appium model. The application under test, here this is the game, is driven by a server receiving commands. The testing code is running the client, which is sending the commands through the network. So every time you want to get information from the game or interact with it, you send a specific command to it. It's a very well-known architecture and has been used in the web and mobile app industries for a long time now. Then you have the embedded runner archetype. To be honest, I didn't see it often outside of video games. Here you don't have a network layer. The tests are bundled into the game and they are running as part of the game. So instead of starting the game normally, you start the runner. The runner can then load the entire game or just a subset of it. And it interacts with the game by simulating inputs and other events. When it comes to pros and cons, especially for the pros, the embedded runner is faster. And this is not surprising, since you don't have to go through a network, you don't have the latency that comes with it. So it's faster. Another crucial advantage is that you can access the internals of the game. So for example, let's say you want to get more currency during a test, or maybe you want to set it to 0. You can immediately do so via the runner, because it has access to the state of the game. This allows you to have a more fine-grained verifications too, because then you can check the state of the game when it makes sense. This also means the range of tests can be larger, because you can write unit tests or end-to-end tests or anything in between, even hybrid tests that might go through the UI or just a subset of it. So you're not stuck with just UI. Something that I find personally very useful too is that you can leverage the type system. What I mean by that is your game already has types inside the language, inside the programming language, representing some data. You don't have to rewrite it on the other side of the network. You can use it directly. And this leads to another advantage. It's easier for feature engineers to pick it up. because they don't have to step out of their programming environment. If they change some types in the tests rely on, they will know immediately and they will be able to fix the test before it joins the main branch, for example. And this is particularly important if your objective is to shift left. So to include people earlier in the modification of the test or the writing of the test. Now, of course, this archetype has its own downside. Using an embedded runner means you are constrained by the programming languages or the game engine that it supports, right? That might not sound like a problem, but let's take Unity as an example. Unity supports C#. If you want to write tests with an embedded runner for Unity, now you will have to look for people who know C#. It's harder to hire people knowing C# than Python. It also means if you want to train someone, then it, of course, to know the programming language, but also the specificities of the game engine, because the tests are running in it. So you need to know how the game engine works. So beyond the mere technical choice here, this is important to keep in mind as an organization. Finally, one important flaw in this architecture is that it doesn't live beyond the game lifecycle. Since your tests are part of the game, if the game crashes, your tests stop running as well, which can be a problem if you want to detect such crashes. So by default, it won't be an easy way to get around that. Now, this is where the client-server architecture shines. Since your tests are running in a different process, right, like there is a network layer, you're not constrained by the game engine or the programming language of the game. So you can hire people with different technical skills than your feature engineers. In other words, it is agnostic. It is very useful if your company uses more than one game engine. The people learning how to do testing to work can apply their skills to different projects. It's also useful if you don't have access to the code source of the game, which happens to outsourcing company, for example. Last but not least, since it's a different process, your test encompasses the life cycle of the game. So if it crashes or if you need to shut it down, restart it, install it, your test can live through that. And that's pretty useful. But of course, this architecture has its own weaknesses. So since there is a network layer, it adds another layer of complexity. It introduces new classes of error that can be annoying to deal with. And if you really are serious to write good tests, you will have to deal with these failures or potential failures. The network also adds overhead because of the latency. So comparatively, your test will be slower. The server often accepts specific numbers of commands. So if what you're trying to do doesn't fit into these commands, either you won't be able to do it, or you will have to write a custom command, but only if the tool supports it. This is annoying, particularly if you're trying to probe the internals of the game. When talking about the embedded runner previously, I mentioned the scenario where you might want to add currency or change it. Well, here you might have to go through the UI to do that. So if you need to buy currency to modify the state of the currency, this can be annoying because you need to go through a loop of going through menus and then buying some currency. And that's slower than directly modifying the state of the game, obviously. Finally, since everything needs to go through the network, static analysis will be less helpful. So entire class of errors you might have caught at compile time, now you have to deal with them at runtime. And so they will be caught a bit later. Okay, so why does all of this matter? It matters because your current team structure or the structure you wish to have in the future will constrain your technical choice, One archetype might fit your team better than the other. So if you want to write different kind of tests, not just UI tests, maybe an embedded runner will be better because you can choose the granularity of your tests. Same if you plan your feature engineers to write tests themselves. Not having to go through a different layer of indirection will help them get there faster. Or maybe you're developing a game where latency is very important, like it's a crucial factor, and having tests keeping frames might be a problem. Think of fighting games or rhythm games that are good examples of this. If you skip frames, maybe you will miss a crucial, important thing that you're testing. On the other side, maybe you already have a strong team dedicated to testing. And in this case, being constrained to the programming language of the game is not a benefit. So having a client-server instrumentation will be a more obvious choice. It will help you hire test automation engineers from other industries too, or help train people eager to learn the craft thanks to an easier learning curve. So people that want to try that, they will be able to do that faster instead of being involved into learning for months before they can get up and running. Another situation where using a client-server instrumentation is a better fit is when your people are exposed to different game engines. Maybe you're an outsourcing agency and you are working with games built on different game engines. Or maybe you don't even have access to the code source. And having an agnostic tool will help you stay flexible here. Finally, if your game can be tested with a higher latency, then choosing one archetype or the other wouldn't be a problem. You can choose which one you prefer. Now that we covered the two existing archetypes, let's see what are the tools available today. I have made a table listing the different tools, their archetype, and what programming language they support. So let's go quickly through them. First, we have Altester. It follows the client-server instrumentation archetype, and its SDK is open source, which makes it relatively easy to get started because you don't need to go through accepting a license before you can try it. The company behind the tool has a relatively active community on Discord, so that can be helpful too. GameDriver is another client-server instrumentation archetype, albeit not open source. While the tool can be used for any games, it has a strong focus on supporting extended reality applications. And extended reality here means basically it's a term that regroups virtual reality, augmented reality, and mixed reality. So this is the umbrella known as XR or extended reality. Poco is a lesser known tool. It's created by NetEase, and the Unreal support is still in the works, so you can only use Unity for now. And this tool is closely related to AirTest, which is based on image recognition. And in my opinion, that makes it less powerful. Not Poco, but AirTest itself. That's why I didn't list it in the table here. Then you have the official tools. For Unity, this is the Unity Test Framework. It's quite bare bone. It's mostly a wrapper on top of NUnit with some tweaks to make it work well with Unity. It's quite flexible because it doesn't get in the way and allow you to write unit tests, end-to-end tests, everything in between. You can make quite complicated stuff with it too because you have access to the Unity editor if you want to. Then you have the Unreal Automation Test Framework. This one is more complex and featureful. It's hard to avoid C++ completely, even if you can use blueprints. So keep that in mind. Also, it's worth mentioning there has been an attempt or more an effort to introduce an RPC framework for Unreal Automation. It comes as an additional layer you can use to write your test following the client-server instrumentation archetype. It's quite new, and I don't know much about it, but it might be useful to check it out if you want to leverage the benefits of the client-server instrumentation. If you're looking for a test automation tool, I hope this table is helpful. I recommend doing a proof of concept before committing to one, so you can evaluate how easy it is to test what you want to test. Okay, next part is about the people. In software development, we think a lot of our problems comes from the tech or can be solved by tech. But our biggest challenges are usually people's problems. When it comes to automated game testing, the first challenge is getting started with finding the right people to write the test. The people you're looking for are known under different names. We have SDET, Aqua, test automation engineers, and sometimes they're under the tools umbrella. And if you do a quick observation here, they're all over the place. Sometimes it's about QA, sometimes about software engineering, sometimes tooling. And this is because writing test automation for video games requires 3 distinct skills. The ideal person needs to understand testing and more generally quality control. They need to be familiar with game development, not only technically, but also business-wise. And finally, test automation implies a strong component of software development. And I insist on the word development here. This is not just about code, but also the processes of how we collaborate to build software. So yeah, this really sounds like trying to find a unicorn, and I don't know about you, but unicorns are not very easy to find lately. So instead, I suggest you to use a different strategy. If the ideal person is at the intersection of the 3, you can also make a compromise and look for someone at the intersection of 2 areas only. Of course, it means they will have different profiles initially. A game tester already knows quality control and game development. To become a test automation engineer, however, they need to learn programming and more generally software development. This can be a steep curve, but this evolution already has been seen in other industries, like in the web development, for example. Then you have the software engineer working in video games. What they miss is knowing proper quality control. This is even more important in the context of automation. This one is actually tricky because often software engineers are driven by technical challenges. And I have to say, automated game testing is far from rocket science. Test automation for video games has a stronger focus on good code instead of technical prowess, so it might not be very attractive for an existing software engineer. Finally, you have, in my opinion, what is the most promising profile, the SDET working in different industries. They already know test automation, just not for video games. So it's really easy to teach them the specificities of automated game testing, so they can be up and running quickly. They mostly have the skills, and coupled with the attractiveness of jobs in the game industry, because a lot of people want to work in video games, usually it makes them easier to hire than the 2 others. So if you're willing to make a compromise and train people instead of looking for a unicorn, here you have 3 different profiles you can pick from. You can either hire them or find someone internally willing to make the move. But often you will have to hire someone, or you will do that, right? Like, this is the choice you will take. So I can give you some tips for writing the job description for such people. This might sound basic, but believe me, I've looked at tons of job description, job posting, job listing, and it's staggering how most of them don't follow these simple things. First and foremost, have the word automation in the name. We've seen it before. People writing tests for games can have many different titles, but generally all of them have the word automation. If you don't that, you create 2 problems. You don't signal to people unqualified for the job that it's a strong requirement, and you also signal, rather than if you don't do that, you make it harder for the qualified people to find the job online. So make it clear and put it in the title of the job description. Even in parentheses, this is good enough, but do it. Make it clear that it's for the game clients, or maybe the game front end, or whatever you name it, but basically this is this concept. Here again, this is to avoid misleading people. Test automation exists in multiple areas. One of them is the backend, for example, and people testing backends also exist in video games, so they will have a similar title. But the skills are not the same, and someone wanting to work on backends might not be comfortable with game clients. So you don't want them to apply for the position and realize too late this is not what they wanted. Talk about the game engine you're using. Game engines are widely different, so explicitly say which game engine you expect the person to know. I know it's tempting to cast a wide net, but since they are very different, like especially for test automation, it will make a lot of difference. So if you're using Unreal, for example, don't mention Unity. These are the three most important ones. And then you have what I call nice to have one. Clarify if the person is supposed to own part of the CI infrastructure. DevOps and build engineer are totally different positions. Like they don't have the same skills. So don't expect everyone to know to do that from the get-go. But if you do, clearly say so. Say if they will have to make changes to Jenkins configuration or get their hands on GitHub Actions or TeamCity. Say what team they will collaborate with. This one is not for every job description, to be honest, but it will help the person understand if they are expected to train others or help the team shift left, or in general, like what is the organization of the team. And finally, one that is nice to know upfront is about your testing infrastructure. Do you have any? What is it? Unit test, end-to-end tests, anything else? It will signal if everything needs to be done from scratch or not. Again, it sounds obvious when stated, but it will make a big difference on the type of candidate you get. And now, the best for the end, we will see a blueprint you can implement for your own needs. The blueprint is divided in three phases: the initial work, its expansion, and a phase dedicated to shifting left. The first phase can be reduced to a question: what to build first? And the answer is simply, you should write a single test. It sounds silly, but there are many things that you will have to figure out. And if you don't want your test infrastructure to crumble over time, you need to take it slow. You can write any test you deem valuable, identify what is the most valuable thing to test first. Pick something more complex than a unit test, but keep it simple. Aim for a quick win. Whatever test you end up with, there are three things I think you should pay attention to. The first one is very important. Make sure it's easy to run locally. You should be able to run the test from the code IDE or from the game engine editor. If you want people to write tests fast, they should be able to run them locally and not wait for the CI to confirm or dismiss a hypothesis. So it's important to tighten the feedback loop. Similarly, the test shouldn't take too long to execute on CI. End-to-end tests are notoriously long, even more so in video games. So if you go this route, don't try to test too many things at once. You will likely have to change the test regularly at first, so take time to make sure the code is easily maintainable. Once you're happy with your test, one very important thing is to integrate it into the lifecycle of the build. So add it to the continuous integration infrastructure. Here you can decide how often you want this test to run. Do you want to run it for every single change? That means including it in the main branch, but also in PR branches, right? Like in the life cycle of this development elements. This is useful if you want your feature engineers to know if their changes have broken the tests. If crashes are a regular occurrence, it can be also very useful because you will know about potential crashes before they reach the main branch. If you're too frightened to run it for every single change, make sure it runs at least once a day. A nightly run can be acceptable, but honestly, if you seriously want to reap the benefit of such tests, I recommend to run it at least for every new change on the main branch. It doesn't have to be for the PR, but the main branch is important. So you can be on top of things when things go wrong. Finally, if no one is monitoring the test failures, the test is pretty much useless. So make sure to notify someone when it failed. Usually it will be the test automation engineer, the one that you just hired. But if you're lucky, you might have an eager feature engineer that wants to be aware of that too. Now you have a single well-written test. It is running daily in your CI pipeline, and you can be on top of any failure given signs of problems. Congratulations! This is the very first vertical slice of test automation. And now has come for phase 2, expanding the effort. In this phase, the idea is to increase the number of tests, just enough to identify problems with the test infrastructure. Here you don't have to write dozens and dozens of tests, just a few. The right number of tests is up to you, but I can recommend 5 as a magic number if you really want to have one. Once again, you will have to decide what kind of test and what area of your game is the most valuable to be tested. I personally think smoke tests are a good option. For example, you can check the first time user experience, if it works as expected, or critical features are also pretty interesting. You can launch the game, open the important feature, and check that the game is not crashing. This kind of stuff. Once you have a few tests, you will be able to gauge their flakiness. Every game is different, and there are many reasons why tests fail. So it's a good time to gather experience and build a small framework fitting the needs of your game. When you get errors, evaluate if it's easy to understand quickly and provide enough information to fix the issue quickly. If that's not the case, go back to your code and improve it until you reach this point. It means having meaningful errors that almost anyone, not just test automation engineers, can understand. A few things that can help with that is first to fail fast. When you fail fast, not only you save time, but the byproduct is that the detected error is closer to the root cause of the problem. This helps investigate issues. 2, be specific, especially in your error messages. So try to say why the codes failed at what it was trying to do, and and why it didn't work out, right? Similar to that, use custom exceptions and give them proper error messages. So, for example, a default timeout without any info is useless because you will have to find where the timeout happened and why there is no messages, right? Like just why just timeout after some time. And this is pretty much useless. It will waste some time on your side. So try to add more information here. Okay, let's take a step back. You might wonder at this point, why are we writing so few tests? Doing all of what I've just described with many tests is a pain. That's why you do it with only a few tests, not hundreds. It will help you understand how to test your game well, and it gives you the room to improve stability. If you do that with too many tests, you will have to put out fires constantly, and you won't have the ability to improve your test infrastructure. And that's because flakiness is your biggest threat here. Potentially, a lot of different people can be interested in the test results. It can be QA, it can be feature engineers, it can even be content designers. If you can't trust the results of your tests, and they won't trust it either, right? They will ignore them. That's why your error messages should, at the very minimum, be specific and clear on what is going on. Sending a notification to someone saying something went wrong is not acceptable. The results are supposed to be signal instead of noise. That's why we focus on a few tests at once. It gives us a chance to reach a point where everyone can see test automation as valuable. This is something that takes time to get right, so be prepared to manage people's expectations. Especially the people that are in managing position, usually they want to have to move faster. Automation is supposed to do that, but initially it will take a lot of work to figure out how it's stable. And it's not uncommon to have people that don't understand immediately why things don't go faster at once. So try to manage their expectation. When do you know you're done with phase 2? For that, you need to fulfill 3 criteria. Your tests are stable. Ideally, they fail only when there is an actual problem in the game or in the test, because the game has changed enough that the test needs to be updated. You can identify the reason a test failed very quickly, every time or almost every time. And 3, you feel like you're ready to add more tests. Your test automation engineer should start to get bored at this point. Basically, you have enough bandwidth to do more. And once you reach this point, you have a choice. Either you continue the expansion, you iterate to add few more tests each time, following the same steps as we just seen, or you try to shift left. And that's our third phase. Shifting left here refers to the practice of moving testing activities earlier in the software development lifecycle. That is the left side of the development island. If we look at key aspects of shifting left, we have testing early, sometimes even in planning and design phases, some amount of test automation, that's what we covered so far, and continuous feedback. So this is the CI/CD part. But something we didn't talk about is developer involvement. And developer involvement, for developers understood as feature engineers here, is basically encouraging them to write tests, but not just unit tests. And before they can do that, they need guidance. So we need to write some nice looking documentation they can go with when they need to. If you don't know where to start, I can recommend using the data axis approach, where you split your documentation in 4 areas, So the 4 areas are tutorials, how-to guides, technical references, and explanations. Mob programming is also a good fit to transfer knowledge here. If you don't know about mob programming, this is similar to pair programming, but with more people. One person codes while the others observe and offer guidance, and engineers take turns in 10 minutes interval. This can be done remotely as well. So here I put the website that explains how it's done. So you can allocate some sessions and do that with multiple feature engineers at once and show them how the test automation works and answer questions they have. And so once you think it's time to share the ownership of the test, change who is getting notified. Ideally, when a test fails, the feature engineer that introduced the change should be notified. On PR, this can be the person who created the PR or the last person who committed the changes. Something I would recommend doing when notifying someone is to make it public. If it's done via private messages, it's easy to ignore, and in my opinion, it dilutes accountability. At first, it might sound a bit harsh, but that's an effective way to encourage responsibility regarding test failures, especially if the person that is notified is not there. Maybe they are sick today and the automated infrastructure just pinged them, but someone can pick it up instead of them. Don't hesitate to use emojis. This can help readability, and also no one wants to have that name associated with the poop emoji, so maybe you want to use that. On that note, I remember attending the Game Quality Forum 2 years ago, and people from PadShark on stage said how notification helped them to ensure feature engineers would take the test result seriously. So this can be an important part of your test infrastructure, because in the end, notifications end up being the main interface between the test result and everyone else. So you will have to talk with the feature engineers and cater to the needs of the different teams. Sometimes they will have specific requirements, like which channel you should send things to and how it looks like. So don't expect a one-size-fits-all solution on the long term. Now we have some tools. By now, you might think feature engineers are ready to take care of some tests, especially failures, right? We have documentation, we train them a bit with mob programming. But believe me, at first they will be lost. They won't know how to fix the test. And this is expected. This is normal. Test automation engineers need to sit with them and to fix the problem with them together. Pair programming is a very good option here. You can build trust, and if you don't hesitate to switch role between driver and navigator, you can transfer knowledge very quickly. You can also answer questions that they didn't think of asking before. At the end of this phase, you should be in a very good place. Your test automation engineers will have room for advancing the infrastructure. So they will be able to think of different flows, different layers of testing to run at different times. The knowledge around the test infrastructure will be shared among many people, which reduces the bus effect. So that's good. And your future engineers will be able to write their own test scenario. And sometimes things that the test automation team or the QA team didn't think about. So this can be very useful. Okay, we're reaching the end of this presentation, so let's do a quick recap. It is important to choose your tools well, because it will be constrained by your current or future team structure. You will need to find the right people, so please be willing to make some compromise. Believe me, there are not many people doing what I do. So instead of trying to find the perfect person, commit to finding someone good enough and train them seriously in the skills they are missing. You'll go faster this way. Start small. This way you can ensure you build rock-solid foundations first and can expand from there. Do not only start small, but grow slowly as well. The biggest threat to test automation in video games is having the engineering team not trusting your results. By doing that slowly, you ensure your infrastructure is not crumbling under its own weight. If you want to go further, I invite you to read my blog on gameconductor.net. I've compared the different Unity test frameworks, for example, and I also maintain a skill tree necessary to become a QA automation engineer in the video game industry. If you have any question, I encourage you to send them to me, or maybe you can post it under this video. And finally, if you consider you are considering test automation for your team, but you are not sure how to move forward, I would be very glad to help. I'm available for freelancing work starting in October 2025, so this year. And feel free to send me an email or a direct message on LinkedIn. I would be very happy to reply to you quickly. That's it for this presentation. So post your question wherever it makes sense. And I see you next time. Bye.